So today we will look into flip-flops, and basically there are about 4 flip-flops. Okay, SR flip-flop, which is also called set reset flip-flop. Then the second one is D flip-flop. So sometimes it's referred to as data flip-flop. Sometimes it's referred to as delay flip-flop. The third one is JK flip-flop. Can someone tell me what's the full form of JK? JK. What's JK?
So it's the inventor's name. I forgot the name.
Sorry?
The inventor's name.
Correct. Correct.
Sir, is it Jack something? So like Jack
Yes,
Kirby?
Jack Kilby. Jack Kilby. That's right. Okay, so he was the inventor of an IC. Okay, so this flip-flop is named after him, JK. Fine, good. So the next one that we have is T flip-flop, which is nothing but your toggle flip-flop. Okay, so 3 important things: truth table, characteristic table, excitation table. Now, why do we need this? We need this for counter designs. We need this for designing synchronous circuits. Okay, we need it for designing mod circuits. Okay, if I tell you to design mod 6 counter, then you'll be needing these tables. Okay, so these 3 tables are very much important. Okay, so please concentrate as I teach you all. Now, initially, okay, always the clock is very much important. Okay, so whenever the clock is enabled, okay, whenever the clock is high, then only I will consider the operation of my circuit. Now, in the initial state, okay, I have considered the clock to be 0, which means the first state I will not be taking. Okay, so it doesn't matter if your S and R is 0 or 1, it doesn't matter because the clock is what? 0. So if the clock is 0, okay, there's no input, which means whatever input is there, it's not of any priority. So my output will actually be what is in the memory previously. Qn is nothing but the previous output. Qn plus 1 is the next output. Okay, or we can term it as next state. Okay, next state output, ns. Right, so now let's get started with the combinations. So we will take from here 4 cases: 0 0 0 1 1 0 1 1. So in all these 4 cases we will keep our clock to be high. Okay, so which means we are giving some valid inputs. So the first state, let's take 0 0. So when I give 0 0, which means there's nothing given, so the output is going to remain whatever is in the memory. Always remember your output follows, okay, your output follows the S values. Okay, when the values are different. Okay, here I have 0 1 and 1 0, but here I have 0 0 and 1 1. So whenever the values are different, okay, I hope you're following. Whenever the values are different, 0 1 1 0, then the output is actually equal to S. Okay, the output is actually equal to S. Whenever I have 0 0, then the memory is going to be in place, and whenever I have 1 1, this state is actually not needed. Okay, or we can call it as an invalid state. So that is one downside of having an SR flip-flop. Okay, so we neglect using SR flip-flop just because of this invalid state. If in case I do not have this invalid state, then I would have used my SR flip-flop extensively, but it's giving me an invalid state, so I do not want to get into this invalid state. So the best thing is I will stop using this flip-flop. I will not use it much. So which means we are having only 0 0 0 1 1 0. Only 3 states are usable. The last one becomes not usable. Okay. So students, any doubts still here till the concepts that I have told so far? Any doubts, please ask. We can discuss on it.
No, sir.
Fine. So now we'll move on to the next one, which is, now this is the truth table. Okay, truth table. And now we will move on to something called characteristic table. Right. So in characteristic table, what will happen is one bit will add. Okay. So here I have given as qn plus 1. Qn plus 1 will remain the same. R, S. So what I will do here is I will have qn. Okay. This clock I have mentioned here only for your reference. Okay. So I am trying to say here that if in case your clock is 0, then your output will have the memory. Okay. Output will remain whatever was there previously. So previous state is also going to be in the next state. There is changes are not going to happen in memory. This is what I'm trying to say if your clock is 0. Okay. Memory is going to change only when there are different values 0, 1, 1, 0. Okay. If not, then even with 0, 0 case also, it's going to remain with the memory state. Previous state is going to be in the next state as well. Okay. Now let's move on to characteristic equation. So here in this characteristic equation, you can in this characteristic table, you can see that instead of clock, what I'm doing is I am having an extra bit. Okay, and that I am naming as qn. So this qn is nothing but your present output. Okay, qn plus 1 is your next output. So as usual, I'm going to take a 3-bit combination ranging from 000 to 111. Okay. Now, how do we make use of this? As I always tell you, have a logical bifurcation here, okay, and then it becomes easy, right? So let us draw a logical bifurcation here. Okay, fine. So now we have to look at the truth table. Okay, so if you look at the truth table, when you have 0, 0, okay, when you have 0, 0, what is what you have to receive? Whatever is in qn, right? So 0, 0, what is in qn now? Someone please respond, don't be inactive. What is in qn now?
0.
0, yes. So this 0 will come and sit here. Okay. Now we will take another case 0, 1. So I am not bothered of what is here in my qn. Okay. 0, 1 exclusively will give me the value of s. 1, 0 will give me the value of s. 1, 1, I know that it is invalid. 0, 0, whatever is in the memory. What is in my memory now? 1. Okay, so that 1 will come and sit here. Similarly, 0, 1, I'm going to get the value of s. 1, 0, the value of s. 1, 1, invalid. Any doubts here, students? With this table, any doubts up till this point?
No, sir.
Okay. So truth table, you are just knowing what is SR and what is your next state. Okay. So in characteristic table, you want to know what was previous and what is going to be next. Right. So for that, now how do I decide these are going to be zeros and these are going to be ones? This is nothing but your normal bit combinations, 3-bit combinations from 000 to 111. After that, I will draw a line, okay, a logical line, and then I will check what is in my qn. So accordingly, I will put that in my qn plus 1. So this becomes my characteristic table. Now, once you have this, okay, getting a characteristic equation is very easy. What you will do, you will just take these values and put it in the K-map. Okay, so this is your 0, 1, 2, 3, 4, 5, 6, 7. Okay, so accordingly, you value your cells 0, 1, 2, 3, 4, 5, 6, 7. Okay. So accordingly, those values we just map it here. Try to get a good group, and once you have a majority group, you will get an equation, and that is called your characteristic equation. Right? Truth table, only your input combinations and output. Characteristic table, input combinations, output, and previous state. Characteristic equation, I'm taking the help of K-map, and I'm getting a characteristic equation. Any doubts till this point?
No,
Can
sir.
I proceed?
Yes, sir. No, sir.
Fine. So the next one that we will be looking into is excitation table. Okay. Now many times you would have seen circuit excitation. Okay. What makes the circuit excite? What levels of combination that you have to give? Okay. So I would say this excitation table is very much related to your characteristic table, because it has both present state, next state, and inputs. So S is there, R is there, Qn plus 1 is there, Qn is there. Just that they are rearranged. Just that they are rearranged. Okay. So again, I am going to get back to my truth table format. So what is my truth table format? Okay, 0, 0, 0, 1, 1, 0, 1, 1. That's it. I'm not going to have a 3-bit. Okay, characteristic equation is going to have 3-bit, and here I'm going to have only 2-bit. But instead, I'm going to derive values from this characteristic table and put it here. Okay, so now we have to do something called grouping. Okay, so Qn and Qn plus 1. So just see wherever it is 0, 0. So I have Qn is 0, Qn plus 1 is also 0. Here also it's 0, and here also it's 0. So what I have to do, students, help me. What do I have to do? Tell me, what do I have
So
to
if
do?
the zeros are there, then we need to write it down as zeros. Otherwise, we need to write it down as X, like if it's changing.
Correct. So here also we will have to do this. Okay. So now I need to combine them. Okay. I need to combine these 0, 0 and 0, 1, because I have here also 0, 0. I have here also 1, 0, 0. So this excitation table is a consolidated table of characteristic table. Okay. Are you getting me? Are you all getting me? This is a consolidated table of characteristic table. So this 0, 0, I will just mention as 0. This 0, 0, I will mention as 0. Now this 0, 0, I will make it as only 0. 0, 1, I will take it as don't care. Fine. Now I will look for 0, 1 combination. Okay. Qn should be 0. Qn plus 1 should be 1. So where do I have it? 0, 1. Okay. So I just have one such combination. Okay. Only one such combination I have. So what I will do, directly I will take this 1, 0. This 1, 0 directly I will take SR value and I will put it here. 1, 0. Any doubts, students? Any doubts?
No, sir.
Okay. Now look for 1, 0. Okay. Your Qn should be 1 and here it should be 0. So I have only one combination as such. Right. So 1, 0. So Qn is 1 and Qn plus 1 should be 0. So I have only one such combination, right? So inside this, what I'm going to do is I will take these values, which is 0, 1. These will be coming here. Okay. Next, I'm looking for 1, 1. Okay, both should be 1. Your Qn should be 1 and Qn plus 1 also should be 1. So how many combinations do I have here in my characteristic table, students? How many combinations do I have?
Sorry, no, 4 combinations.
Are you sure? 1, 1 combination, how many do I have in my characteristic table?
2, sir.
So 2.
2. Okay. So those only I will be taking. So I have Qn plus 1 here. Okay. And Qn here and Qn plus 1. Both are 1, 1. And here also I have 1, 1. What is this 1, 1 I'm talking about? This 1, 1. Qn is 1. Qn plus 1 is also 1. Here also it's 1. And Qn is also 1. So what I will do, I will just compare these two rows now. Okay. So R, I have 0, 0. So R will be directly 0. Yes, I have 0 and 1. So I will take it as don't care. Any doubts here, students, with the excitation table? Any doubts? So
No, sir.
with the truth table, we take or we extract characteristic table. From the characteristic table, with the help of K-map, we take or we make sure that we get a characteristic equation. From the characteristic table, I am consolidating things and taking or extracting something called excitation table. So this is the most refined format. Excitation table is the most refined format. Okay. So similarly, now you can get equation for S and R. Okay. Only this is high. So which means it is Qn. Okay. So S is equal to Qn plus 1. Okay. Then your R is equal to Qn. Or you can take it as Qn plus 1 bar. Okay. So ultimately what you can do, you can just take a K-map of this, okay, S and R, and you can get the equations. Now do not worry about these equations, okay, characteristic equation and excitation table equations. Only thing now you have to concentrate on getting these tables right. Rutesh, any doubt do you have?
Sir, can you repeat it again, sir?
Which one? Excitation table?
Yes, sir.
Okay. So when I am looking at 0, 0, okay, first I will take this case, 0, 0 case. So here I have to search for Qn. Okay, so Qn is here and Qn plus 1 is here. So I have to look for 0 and 0. So 0 is here for Qn and for Qn plus 1, 0 is here. Then there is one more combination, 0 and 0. So I will combine both of this. Okay. Both of this I will combine. These two zeros, okay, I will make it as a single 0. And these two zeros, I will make it as a single 0. Rutesh, understood till this point?
Yes, sir. Yes, sir.
Okay. Now S has two zeros. So the same concept applies. I will make these two zeros as 0. Okay. So that is what is here. Now R has two values. So I'm confused now. Should I put 0 or should I put 1? I do not know. So what I will do, I will not put 0. I will not put even 1. Instead, I will put it as what? What will I put it as? I'll put it as a don't care. Okay. So similar analysis you have to do for 0, 1 case also, okay, where your q is 0 and qn plus 1 is 1. Okay. So we have only one such case. Okay. We have only this case which is matching that criteria. Okay. So I have 0 here. I have 0 here and I have 1 here. So that same 0, 1 is here, 0, 1. And what is my SR value? Subsequent SR value? 1, 0, right? So that 1, 0 comes here. 1, 0. Any doubts, Rutesh?
No, sir.
Okay, fine. So this is how you actually go about and find out the characteristic table, excitation table from the truth table. Okay. Now let us go to the next one, which is D flip-flop. So here in D flip-flop, you just have one input. In SR, you had two inputs because S and R. Okay, so you need to have two. So input and output, that is only your truth table. Okay. So when your D is 0, your Q is also 0, and D is 1, your Q is also 1. When D has a don't care, then it's going to be your previous memory. This is the property of D flip-flop. So whatever you give to D, here your D is 0, 1, the same 0, 1 comes across your output. So now we have to extend this 1 bit to 2 bits. 0, 0, 0, 1, 1, 0, 1, 1 is my normal combination. So now I'm going to check, what is my D, and accordingly I will decide my next state. So D is 0, so 0 will come, 1, 0 is here, 0, 1, 1. So you can see that, okay, all these values 0, 1, 0, 1 is equal to your output. So what I can say, my next state is nothing but D. Is this correct, students? Understanding?
Yes,
sir.
Okay, fine. So whatever is at your D, the same thing is coming at your output. Okay. So this becomes your characteristic table for D flip-flop. Now, how will I go about with excitation table? I have to look for combinations, right? So 0, 0, 0, 1, 1, 0, 1, 1. So I'll have to check for 0, 0. So in 0, 0, my D is 0. So I bring that 0 here. Next 0, 1, D is 1. Next 1, 0. Okay, D is 0. Next 1, 1, D is 1. Simple, right? Yes?
Yes, sir.
Fine. Students, any doubts? Please ask. Any doubts here? Can I proceed?
Yes, sir.
Okay. Next, coming to your JK flip-flop. So in JK flip-flop, you have J and K. So 0, 0, 0, 1, 1, 0, 1, 1. Okay, your output will follow J. So when 0, 0, the same thing, memory state. The only difference that happens between SR and JK is that, okay, during 1, 1, it was an invalid state. But here during 1, 1, it's going to be a Q bar, which means whatever is in the memory, that will be toggled. Okay, so 0, 0, nothing changes, same memory remains. Then 0, 1, 0 comes, 1, 0, 1 comes, 1, 1. In SR, it is invalid. Here it is memory, the complement of memory, which is QN bar, right? So I will extend this with 3-bit combination, 000 to 111, okay, and I will look for 0 0. So whenever it is 0 0, whatever is the memory, the same thing comes. 0 1, J comes. 1 0, J comes. 1 1 is the tricky part here. 1 1 is what? What is 1 1 here?
Complement of Q.
Complement of Q. So now 1 1 is here. Okay, 1 1 is here. What is my Q? Q is 0. So that will be a complement of 0. 0's complement is what? 1. Okay. Then in 0 0, whatever is in the memory, the same thing comes. Okay. 0 1 J, 1 0 J, 1 1 Q bar. So 1 complement 0. Put this in K map, you will get your characteristic equation. Any doubts, students? Any doubts?
Sir.
Okay. So using my characteristic table, now I'm going to regroup them, right? So Q, Qn. Okay, so just have a look at this excitation table. Okay, so you can see this excitation table here. So ultimately what we are doing, we are trying to rearrange them. Okay, so if you can see, we will look at 0 0. Okay, so you should have the combination here 0 0. Okay, so here 0 0, J is going to be 0 and K is going to be don't care. 0, don't care. Similarly, I'll be looking for 0 1. I have two combinations of 0 1 here. J is going to be 1 and K is going to be don't care. J is 1, K is don't care. Okay. Similarly, I will be looking for 1 0, 1 and 0. I have two combinations, right? 1 0. Here also I have 1 0, right? Two combinations. So here my K is going to be 1 and my J is going to be don't care because it is 0 and 1. Okay, so this one is also done. Next, when I have 1 and 1, so 1 1 1 1, so I'll be looking at that format, this one and this one. So K is directly 0, J is going to be don't care, right? So that's how we get the last one. So if you know the truth table, okay, then it's going to be easy for you to continue with characteristic and excitation. Now we'll see the last one, which is your T flip-flop. Okay, so in this T flip-flop, whatever is the input, okay, say for example, if 0 is your input, your memory will remain the same. If 1 is given as T, okay, for T, if T is equal to 1, then it's going to complement things. Toggle is nothing but complementing things. Okay, so that's the truth table. So now let's move ahead with the characteristic table. I extended, okay, 0 0 0 1 1 0 1 1. So here now I have to look for T's column. Okay, only concentrate on T's column. So if you can look at this, okay, so just concentrate on this. Fine. So your P is equal to 0, right? So since your P is equal to 0, what is going to happen? Qn should come. So Qn is 0 and this is 0 comes in 6 here. Similarly, when 1, what should happen? It should complement. So 0 becomes 1. 0, the same thing comes here. 1, it is complemented and 0 comes. Okay. So this is your characteristic table. Put it in your K map. you will get a equation like this. Okay. So as you can see here with your characteristic table, okay, you are going to get equation Qn, which is XOR with T. Okay, so directly, in fact, with visual inspection, okay, you can go ahead and get the equation, right? So if you can see here, your wherever you have one, you have to look for those combinations. So you have one here, so it's a Qn bar because it's a 0, and then T. Then here you have 1. Okay. So you are looking at only these two cases. Only these two cases, because only these two are having high values, right? So it's 0, 1. So Qn is going to be low, which is Qn bar, and then T plus Qn, which is high, okay, and T, which is low. Okay, so ultimately I can even write it as Qn, which is XORed with T. So I hope characteristic table is understood, right? Students, any doubts?
No, sir.
Fine. So moving ahead, as I told you, your excitation table is nothing but an extract of your characteristic table. So Qn plus 1 comes here, and then T comes here. So 0, 0, 0, 1, 1, 0, 1, 1. So I'll be looking for 0, 0, right? 0, 0. So when it is 0, 0, my T is what? 0. So this 0 will come here. Next case, 0, 1. T is 1. Next 1, 0, 1, 0, T is 1. 1, 1, T is 0. So you should be knowing the property of a flip-flop, and that is known by its what? Is it known by its excitation, characteristic, or truth table? How will you know the basic property of a flip-flop?
Truth table.
Correct. Using truth table. So using truth table, we can derive characteristic and excitation table. So I hope these concepts are cleared, right? If you have any doubts, you can feel free to ask, because these concepts, whichever I have discussed so far, will help you in flip-flop conversions also. Okay, if you want to convert from one form to another form, this is very much needed, because you need to know the required truth table, needed truth table, okay, which is the required flip-flop, which is the available flip-flop. So you will have to know the truth table of all these 4 flip-flops. It's a must. Okay, is that fine, all of you? You all are clear with the concepts discussed so far? Yes.
Yes, sir.
Okay,
Yes, sir.
thank you.